In this video, we are going to use z-scores to find proportion or percent more than or less than a given data value. Now, in the standard normal curve, the following three quantities are equivalent: the percentage or the proportion, the probability, and the area under the normal curve. So we're going to use all of those things to help us with these particular problems. So three things we're going to do. If we want to calculate the percentage or proportion less than a given data, what we're going to do is we are going to find the location of the data in comparison to the mean by calculating its z-value, or sometimes called z-score. So that's the formula we see here. Using the standard normal distribution table, we're going to find the area under the normal curve to the left of the z-value, and then we can convert that area to the percentages or a proportion. Let's look at an example. So in this example, we're going to look at the time taken to assemble a car in a certain plant is a random variable having a normal distribution with a mean of 20 hours and a standard deviation of 2 hours. What percent of the cars can be assembled in less than 19.5 hours at this particular plant? Well, we're going to take those values. So all I've done here is you can see that our that mu symbol, that mean is 20. This is sigma is 2. To find the percentage of the cars that can be assembled in less than 19.5 hours, we need to find the area under the normal curve to the left of 19.5. So that's kind of what the normal curve would look like. That's where 19.5 would hit if we had a mean of 20 and a standard deviation of 2. So that's what it would look like. But how could we really interpret that, unless we had some type of calculator or some type of chart? And let me show you what you need to do. First thing we're going to do is we need to find, well, what is the z-value that corresponds with 19.5? So we're going to take that 19.5, we're going to minus off the mean, in this case 19.5 minus 20, and then we're going to divide by the standard deviation of 2. We're going to get negative 0.25. So what does that mean? Well, we're going to need to find that on a standard normal distribution table. So here's a table that shows us. Now, you're going to find the ones that have the negatives on them. Negative 0.2, you're going to go over until you hit negative 0.25. And so we know that the area under the normal curve to the left of this particular z-score or z-value is 0.40129. Now, what does that mean? Well, we can convert that area to a percentage if we just multiply that decimal by 100. So we can say that 40.129100 is the percentage of cars that can be assembled in less than 19.5 hours. So you can round that to 40 if you were going to the nearest whole number. We have rounded to the nearest thousandth. Now be very careful, because if the question is worded and it says calculating the percentage of the proportion more than, it's pretty much exactly like what we see there, except in step 3. To find the area, we need to subtract from 1, because remember, that table is going to show us the area to the left of that score. The more than, we want the area to the right of that score, and so just subtract that from 1. It's called the complement. So let's look at that same exact question from before, except one thing has changed. It says what percent of the cars could be assembled in more than 19.5 hours at this plant. Now remember, we've already found that value. You just have to take it off of 1. So that 0.40129 value, just subtract it from 1. And it's roughly 60%. When rounded to the nearest whole number. Depending on how your problem is worded, we could have even left it 59.861% if we needed to be that accurate. Just watch how they've asked you. But it would make sense if 40% would be the amount that was made less than 19.5 hours, then 60% would be the more than 19.5 hours. So that's a little bit about how we use z-scores. Thank you so much for watching. You have a good day.